Good morning, students. Welcome back to chemistry classroom once again. Today I will discuss few examples of separating of mixture. But before it, here is a summary. Look at the book. Type of mixture and methods, when applicable, and example. First one, sieving. When the particle size of the components are different. We can apply the sieving process when the component particles basically are different sizes. Example, separating bran from flour, stone from sand, etc. Next, magnetic separation. When one of the constituent is magnetic, which component normally attached with magnet. If we apply magnetic separation, we can easily separate the component from the mixtures, like separating iron from sulfur. Sublimation. When one of the components sublimes and the other does not. So normally we can apply the sublimation process if we want to separate the substance which does not sublimes. Separating ammonium chloride or camphor from salt or chalk. Next, dissolution and evaporation. When one of the constituent is soluble, we can apply the dissolution and evaporation process for separating the components, basically which one is soluble in solvent, like salt or sugar from sand. Chromatography. When the whole mixture is soluble, separating pigments of an ink or flour. Next, solid liquid mixture, sedimentation and decantation. When the mixture is heterogeneous, when the component of a mixture are heterogeneous, then we can apply sedimentation and decantation process. By this process, we can easily separate out like sand or chalk from water. Next, filtration. Same process when the mixture is heterogeneous. Distillation. When the mixture is homogeneous or heterogeneous. If the component of the mixtures basically are heterogeneous in nature or homogeneous in nature, then we can apply distillation process to separate them, like separating water from salt, sugar and sand solution. Next, liquid mixture. Using a separating funnel. When the liquids are immiscible means the component of the mixture basically not mix up with each other. So when we apply separating funnel, we can easily separate the immiscible liquids like oil from water. Fractional distillation. When the miscible liquids differ in boiling point by 20 degrees Celsius or more. We can apply the fractional distillation process to separate the component of a mixtures which are both soluble in solvent and both have different boiling point more than 20 degrees Celsius. Like alcohol from water, benzene from toluene. Here are some examples about separating mixtures. First one is sand-water mixture. Sand can be separated from water by filtration and distillation process. The water distilled out and leaving the sand as a residue. When we use filtration process, normally the water just distill out. Same way, sand is leaving out after the filter paper as a form of residue. A salt solution. By distillation, the water can be obtained as the distillate and the salt as residue. Next, a salt chalk mixture. Sugar is soluble in water, but chalk is not. So the sugar can be dissolved out in water and leaving the chalk behind. The mixture on filtration will give the chalk as a residue, and the filter and evaporation or crystallization we will get sugar. What is the process? It is a mixture of sugar, chalk powder and water. So when we filtrate, when we apply filtration process, normally chalk powder left on the filter paper as a form of residue. Same when the distillate water we will get, if we evaporate them, normally at the last point we will found the sugar as a form of crystal. An iron filling sawdust mixture. An iron is a magnetic and sawdust is not. So magnetic separation will be convenient method to separate them. I mean, when we move to the any magnetic substance, easily we can separate the iron from the sawdust particles because iron easily attached with magnet. And iron filling sulfur mixture. Two methods can be used: magnetic separation and dissolution of sulfur in carbon disulfide, followed by the recovery of sulfur from solution by the evaporation or crystallization. I mean, when we apply dissolution process, we have to use the carbon disulfide to separate the sulfur from the iron fillings. Carbon sulfur mixture. Knowing that sulfur is soluble in carbon disulfide, but carbon is not, you can suggest the method. Carbon sulfur mixture means, all of you know, sulfur is soluble in carbon disulfide, but carbon is not. So in this way, we can easily separate the sulfur from the carbon sulfur mixture. A water oil mixture. Water and oil both are immiscible liquids. So when we will use a separating funnel, we can easily separate the two components. Remember that like oil, chloroform, carbon tetrachloride and ether are also immiscible with water. So the method will be useful for the total mixture of components. Next, a benzene toluene mixture. As the difference in the boiling points of benzene and toluene 110 degrees Celsius is more than 20 degrees, the two miscible liquids can be conveniently separated by fractional distillation. Normally, fractional distillation is a process by which we can separate the two miscible liquids. Both have different boiling point and it may be 20 degrees Celsius. So difference may be 20 degrees Celsius. So in case of that, we can easily separate the benzene and toluene because their difference more than 20 degrees Celsius. And ink mixture. Ink mixture, if we want to separate the ink component from the mixture, we have to use the paper chromatography. Next, salt, sand, sulfur mixture. Among three components, only sulfur is soluble in carbon disulfide and only salt in water, but sand neither of two solvents. So in case of the mixture, we can easily separate the sulfur by carbon disulfide using, and same way salt dissolved in water but sand not. So the sulfur can be dissolved out in carbon disulfide from the residue containing salt and sand. Same way the salt can be dissolved out in water leaving the sand behind. The sulfur and salt can be recovered from their solution by the evaporating of the solvents. So when we apply carbon disulfide, sulfur is usually separated from the mixture. Then when we normally use the filter paper, sand is residue, and then when we get evaporated the leaving particles, normally salt will be get as a form of crystal. Alternatively, the first salt can be dissolved out water, then sulfur in carbon disulfide. Next, carbon sulfur niter mixture. Carbon sulfur and niter mixture is also known as gunpowder. Gunpowder is an explosive containing carbon, sulfur and potassium nitrate. Only sulfur is soluble in carbon disulfide and only niter in water. So normally gunpowder is a mixture of carbon, sulfur and potassium nitrate. So sulfur is only soluble in carbon disulfide and niter in water. So sulfur and niter can be dissolved out successively in carbon disulfide and water and recovered from the solution by evaporating the solvents or crystallization. I mean, when we use the carbon disulfide, we easily separate the sulfur, then when we'll get evaporate the mixture, then we will get easily separate the potassium nitrate as a form of crystallization. Alternatively, the nitre can be dissolved out fast, then sulfur. So first of all, nitre can be dissolved. After that, sulfur. Difference between mixture and component. So student, here is the difference between mixture and component. You have to learn the difference. First one, mixture, it is an impure substance. Compound, it is a pure substance. Next, mixture, the component can be present in any proportion, but in case of compound, the constituent must be present in a fixed proportion. And third one, the components show their individual properties, but in case of compound, the constituent does not show their individual properties. The component can be separated by a physical means, the constituent cannot be separated by a physical means. So students, you have to learn the difference. And I hope all of you have understood what I have discussed today. So for today, up to this portion, and the next class, I will start the exercise.